Selecting the right terminal strips for high-temperature industrial ovens is critical to ensure reliable and safe electrical connections. When standard terminal strips melt due to extreme heat, several specialized solutions can be implemented. Firstly, consider using ceramic terminal strips. These offer excellent heat resistance, non-conductivity, and high-temperature stability, making them suitable for extreme environments. Secondly, zirconia terminal strips are another option. They are highly durable and corrosion resistant, with excellent electrical conductivity and resistance to thermal shock. Thirdly, silicon carbide terminal strips can be used. These possess high electrical conductivity and exceptional strength at high temperatures. In addition to specialized terminal strips, heat-resistant insulation can provide added protection. Insulation blankets can be used to cover the terminal strips, providing additional protection from heat exposure. Ceramic insulators can be placed between the terminal strips and the oven surface to minimize heat transfer. Heat shunts, such as heat sinks or shunt plates, can dissipate heat away from the terminal strips. Heat-resistant adhesives can also play a role in securing the strips. High-temperature epoxy adhesives designed for extreme environments can bond the terminal strips to a heat-resistant surface. Ceramic-based adhesives offer excellent bonding strength and resistance to high temperatures. Mounting considerations are also important. Mount the terminal strips at an elevation away from the oven's peak heat zone. Ensure adequate ventilation around the terminal strips to allow heat dissipation. Protective enclosures can shield the terminal strips from radiant heat. Additional tips include ensuring that the number 8 high-temperature wire going to the strips is rated for the extreme temperatures encountered. Limit the exposure time of the terminal strips to high temperatures by using timers or automatic controls. Regularly inspect the terminal strips for signs of damage or deterioration and replace them promptly if necessary. Applying heat-resistant coatings to the terminal strips can provide additional protection and extend their lifespan. Selecting the right materials and implementing proper installation techniques are key to maintaining reliable electrical connections in high-temperature industrial oven environments. Proper wiring and connections are crucial in these high-temperature environments. The selection of materials plays a pivotal role in ensuring safety and efficiency. Consider the ambient temperature and the operational temperature of the oven. The terminal strips must withstand these conditions without degrading or failing. Firstly, examine the specifications of the terminal strips. Ensure they are rated for temperatures significantly higher than the expected operating temperature outside the oven. A safety margin is essential to prevent premature failure. Secondly, consider the material composition of the terminal strips. Ceramics, zirconia, and silicon carbide are excellent choices due to their high thermal resistance. These materials maintain their structural integrity and electrical insulation properties even at elevated temperatures. Thirdly, the design of the terminal strip is important. Look for designs that promote heat dissipation. Features such as fins or increased surface area can help to reduce the temperature of the strip. Furthermore, the way the terminal strips are mounted can significantly affect their performance. Avoid direct contact with the oven's hot surfaces. Use ceramic insulators to create a thermal barrier, reducing heat transfer to the terminal strips. Ensuring adequate ventilation is also vital. Airflow around the terminal strips helps to dissipate heat, preventing it from building up. If possible, locate the terminal strips in a cooler area away from the direct heat of the oven. Protective enclosures can shield the terminal strips from radiant heat. These enclosures should be made of heat-resistant materials and designed to allow airflow. When selecting adhesives, opt for high-temperature epoxies or ceramic-based adhesives. These adhesives maintain their bonding strength even at extreme temperatures. Regular inspections are a must. Look for signs of wear, such as cracking, discoloration, or deformation. Replace any damaged or deteriorated terminal strips immediately to prevent electrical hazards. In addition to the terminal strips themselves, the wiring connected to them must also be heat resistant. Ensure that the number 8 high-temperature wire is rated for the temperatures it will be exposed to. Use appropriate connectors and terminals that are also designed for high-temperature applications. Furthermore, consider the environmental factors. Industrial environments often involve exposure to chemicals, moisture, and vibration. Ensure that the terminal strips and wiring are resistant to these factors. Corrosion-resistant materials and sealed enclosures can protect against environmental damage. Proper grounding is essential for electrical safety. Ensure that the terminal strips are properly grounded to prevent electrical shocks and equipment damage. Follow all applicable electrical codes and safety standards. Consult with a qualified electrician or engineer to ensure that the installation meets all requirements. Document all wiring and connections. This makes troubleshooting and maintenance easier. Label each terminal strip and wire clearly. Training personnel on the proper handling and maintenance of the terminal strips and wiring is crucial. Ensure they understand the risks associated with high-temperature environments and how to identify potential problems. By carefully considering all these factors, you can select and install terminal strips that will perform reliably and safely in the demanding environment of an industrial oven. Remember that prevention is key. Regular maintenance and inspections can identify potential problems before they lead to failures. Selecting the right type of terminal strip involves several considerations, primarily focusing on the material's ability to withstand high temperatures and maintain its electrical properties. Firstly, ceramic terminal strips are a popular choice for high-temperature environments. Ceramic materials are known for their excellent heat resistance, non-conductivity, and high temperature stability. These strips can operate effectively in environments where temperatures reach several hundred degrees Celsius without degrading or losing their insulating properties. Secondly, zirconia terminal strips offer enhanced durability and corrosion resistance compared to standard ceramic strips. Zirconia is a ceramic material with superior mechanical strength and resistance to thermal shock, making it suitable for environments where rapid temperature changes occur. Its excellent electrical conductivity allows it to maintain a stable electrical connection even under extreme conditions. Thirdly, silicon carbide terminal strips are another option for applications requiring both high electrical conductivity and exceptional strength at high temperatures. Silicon carbide is a semiconductor material that retains its electrical properties at high temperatures, making it ideal for demanding industrial applications. Furthermore, selecting the right insulation is crucial for protecting terminal strips from direct heat exposure. Insulation blankets made from high-temperature materials like fiberglass or ceramic fibers can provide an additional layer of protection. These blankets are designed to withstand extreme temperatures and prevent heat from reaching the terminal strips. Ceramic insulators can be placed between the terminal strips and the oven surface to minimize heat transfer. These insulators act as a thermal barrier, reducing the amount of heat that reaches the strips and preventing them from overheating. Heat sinks or shunt plates can be used to dissipate heat away from the terminal strips. These devices are designed to absorb heat and transfer it away from sensitive components, keeping the terminal strips cooler and preventing them from melting or deforming. Selecting the right adhesive is also important for securing the terminal strips in place. High-temperature epoxy adhesives are designed to withstand extreme temperatures and maintain a strong bond even when exposed to heat. Ceramic-based adhesives offer excellent bonding strength and resistance to high temperatures, making them ideal for applications where the terminal strips are subjected to extreme conditions. Proper mounting techniques can help to minimize heat exposure. Mounting the terminal strips at an elevation away from the oven's peak heat zone can reduce the amount of heat they are exposed to. Ensuring adequate ventilation around the terminal strips can help to dissipate heat and prevent it from building up. Enclosing the terminal strips in a protective enclosure or box can shield them from radiant heat. This enclosure should be made from heat-resistant materials and designed to allow for adequate ventilation. Other important considerations include ensuring that the number 8 high-temperature wire going to the strips is rated for the extreme temperatures encountered. High-temperature wires are designed to withstand extreme heat without melting or degrading, ensuring a reliable electrical connection. Limiting the exposure time of the terminal strips to high temperatures can help to extend their lifespan. This can be achieved by using timers or automatic controls to reduce the amount of time the strips are exposed to heat. Regularly inspecting the terminal strips for signs of damage or deterioration is essential for ensuring their continued safety and reliability. Any damaged or deteriorated strip should be replaced promptly. Applying heat-resistant coatings to the terminal strips can provide additional protection and extend their lifespan. These coatings are designed to withstand extreme temperatures and prevent the strips from corroding or degrading. Considering these factors will help to ensure that the terminal strips used in high-temperature industrial ovens are able to withstand the extreme conditions and provide a safe and reliable electrical connection. Selecting the appropriate terminal strips for high-temperature industrial ovens requires a detailed understanding of material properties, installation techniques, and maintenance practices. Firstly, when evaluating terminal strip materials, consider ceramic, zirconia, and silicon carbide options. Each offers unique benefits. Ceramic terminal strips are known for their exceptional heat resistance and electrical insulation properties. These strips can withstand continuous exposure to high temperatures without significant degradation, making them ideal for ovens where consistent high heat is present. Zirconia terminal strips provide enhanced durability and resistance to thermal shock. Zirconia's ability to withstand rapid temperature changes without cracking or losing its structural integrity makes it suitable for ovens with fluctuating temperature cycles. Silicon carbide terminal strips offer a combination of high electrical conductivity and mechanical strength at elevated temperatures. This is particularly useful in applications where maintaining a stable electrical connection under high heat is crucial. Secondly, consider insulation methods to protect terminal strips from direct heat. High-temperature insulation blankets, made from materials like fiberglass or ceramic fibers, can be wrapped around the terminal strips to provide an additional barrier against heat exposure. These blankets are designed to reflect heat and prevent it from reaching the strips. Ceramic insulators can be strategically placed between the terminal strips and the oven surface to minimize heat transfer. These insulators act as a thermal break, reducing the amount of heat conducted to the strips. Heat sinks or shunt plates can be used to dissipate heat away from the terminal strips. These devices absorb heat and transfer it to a cooler environment, helping to maintain a lower operating temperature for the strips. Thirdly, consider adhesive selection for securing terminal strips. High-temperature epoxy adhesives are formulated to maintain their bonding strength even when exposed to extreme heat. Ensure the selected epoxy is rated for the maximum temperature expected in the oven environment. Ceramic-based adhesives offer excellent bonding strength and resistance to high temperatures. These adhesives are particularly useful when bonding ceramic terminal strips to other surfaces. Furthermore, optimal mounting techniques can significantly reduce heat exposure. Mount the terminal strips at an elevation away from the oven's hottest zone. This simple adjustment can drastically reduce the amount of radiant heat the strips are exposed to. Ensure adequate ventilation around the terminal strips. Proper airflow helps to dissipate heat and prevent it from building up around the strips. Protective enclosures, made from heat-resistant materials, can shield the terminal strips from radiant heat. These enclosures should be designed to allow for ventilation to prevent heat buildup inside the enclosure. Furthermore, consider several additional tips for ensuring long-term reliability. Verify that the number 8 high-temperature wire is rated for the maximum temperature it will encounter. Using improperly rated wire can lead to insulation breakdown and electrical hazards. Limit the exposure time of the terminal strips to high temperatures by implementing timers or automatic controls. Reducing the duration of exposure can significantly extend the lifespan of the strips. Implement a regular inspection schedule to check for signs of damage or deterioration. Early detection of problems can prevent more serious issues from developing. Apply heat-resistant coatings to the terminal strips to provide an extra layer of protection. These coatings can help to reflect heat and prevent corrosion. By carefully considering these factors, you can select and implement effective solutions for protecting terminal strips in high-temperature industrial ovens. Regular monitoring and maintenance are essential for ensuring the continued safety and reliability of these systems.